Welcome back to AI Talks with Chris and Nita. Today we're gonna be taking a deep dive into something called the Candidate Elimination Algorithm, or sometimes it's called CEA for short. And this is a pretty interesting one. It's an algorithm that's used for machine learning, and it's all about classification tasks. So figuring out which category something belongs to based on the data that you have, and it's actually an improvement on a simpler algorithm called FindS, which we've talked about before, I think. And
yes, we have.
So today we're going to be exploring the what makes CEA so special, what are its advantages over FindS, but also what are some of the disadvantages, because every algorithm has its trade-offs.
Right, absolutely.
So to get us started, maybe you could give us a little bit of a refresher on what that candidate elimination algorithm is. Like, what's the core concept here?
Sure. So the candidate elimination algorithm, basically it's a way of learning from examples. So you feed it a bunch of data. Some of it's labeled as positive examples. Some of it's labeled as negative examples. And the algorithm uses this information to kind of narrow down a set of possible hypotheses about how to classify things.
Okay.
So you can think of it as like, you're trying to figure out, let's say you're trying to figure out what makes a good, I don't know what makes a good cup of coffee.
Okay, yeah.
So you might have some positive examples like, a cup of coffee that you really liked, and you might have some negative examples like a cup of coffee that you really didn't like.
Right.
And then the algorithm is going to look at those examples and try to come up with a rule that can distinguish between the good cups of coffee and the bad cups of coffee.
I see. So it's kind of like a detective in a way.
Right.
It's looking for clues in the data.
Exactly.
Yeah.
It's like a detective trying to solve a mystery.
Okay, that makes sense. And you mentioned hypotheses.
Right.
So how are hypotheses used in CEA?
So a hypothesis is basically just a guess about how to classify things. So for example, a hypothesis about our coffee problem might be a good cup of coffee has to have at least this much sugar in it, or a good cup of coffee has to be made with this type of bean.
Okay.
And so the candidate elimination algorithm starts with a whole bunch of possible hypotheses, and then as it sees more and more examples, it starts to eliminate the hypotheses that don't fit the data, so the hypotheses that are inconsistent with the examples that it's seen.
Oh, I see. So it's kind of like a process of elimination.
Exactly.
Yeah.
It's a process of elimination. It starts with the general set of possibilities, and then it narrows it down until it gets to the most specific hypothesis that can explain all of the data.
Okay, so that's how it works. But how is that different from the FindS algorithm? You mentioned that earlier.
Right. So FindS is kind of a simpler version of candidate elimination. It also tries to find the most specific hypothesis, but it only looks at the positive examples. So it doesn't take into account the negative examples.
Okay. So CEA is more sophisticated in a way because it considers both the positives and the negatives.
Exactly, yeah. That's one of the key differences, and that's what gives it some advantages.
Okay, let's talk about those advantages then. What are some of the benefits of using CEA over FindS?
So one of the big advantages is that CEA tends to be more accurate than FindS because it's taking into account both the positive and negative examples. It's less likely to be thrown off by noisy data or by outliers, data points that don't really fit the pattern.
That makes sense. It's like having more information to work with.
You're right, exactly. Okay. And it also means that it can handle more complex problems where the relationship between the data and the classification isn't so straightforward.
Okay, so it's more robust and more flexible.
Exactly.
Now, you also mentioned that it's more efficient in terms of hypothesis reduction. What exactly did you mean by that? Can you give me like a concrete example?
Sure. So let's imagine we're trying to build a system that can classify emails as spam or not spam.
Right.
So a FindS algorithm might start with a very general hypothesis, like any email that contains the word free is spam.
Right.
But then it might see a positive example, an email that's not spam that also contains the word free. So it'd have to make its hypothesis more specific.
Right.
But a CEA algorithm would be able to eliminate that hypothesis much more quickly because it would also be looking at negative examples, emails that are spam and that don't contain the word free.
Okay. So it's kind of like it's pruning the tree of possibilities more aggressively.
Exactly, yeah. It's pruning the tree of possibilities more aggressively, and that can save a lot of time and computational resources.
Especially when you have a lot of data.
Yeah.
Okay. So CEA seems like a pretty powerful algorithm, but I'm guessing it also has some downsides.
Right, absolutely. There's no free lunch in machine learning. Right? So one of the main downsides of CEA is that it can be more computationally expensive than FindS. because it's
Yeah.
keeping track of a larger set of hypotheses. It needs more memory, and it can take longer to process the data.
Okay, that makes sense. It's like the trade-off for being more accurate, more flexible.
Exactly. And it can also be more complex to implement and to understand, because you have to deal with this whole process of hypothesis elimination, and you have to make sure that you're doing it correctly.
Right, so it might not be the best choice for every situation, like if you have a very limited budget or if you need a really simple solution.
That's right. It really depends on the specific problem that you're trying to solve and the resources that you have available.
So it's like a toolbox. You have different tools, and you have to choose the right tool for the job.
Exactly.
Okay, so to kind of summarize what we've talked about, CEA is a powerful algorithm that can be more accurate and more flexible than FindS, but it can also be more computationally expensive and more complex. So ultimately, the choice of which algorithm to use depends on your specific needs and constraints.
I think that's a great summary.
Great. Okay, so now that we have a better understanding of CEA and FindS, let's put our knowledge to the test. Imagine you're working for a streaming service, and you're tasked with building a recommendation system to suggest movies and shows to users.
Okay.
Now knowing the strengths and weaknesses of both algorithms, which one would you choose for this particular task and why? Think about it. It's a challenge for you, our listeners.
And that's all the time we have for today. Thanks for joining us on this deep dive into the world of AI.
See you next time.